This is Math 2, Unit 13, Lesson 4, Form G. Looking at some homework help today for you guys here, looking at independent and dependent events. The big difference here is independent means they are not connected. Dependent means whatever happens to the first will impact the second. So whatever happens to one impacts the second. So let's look at a couple samples here. We'll go for number 1 as well, mine as well. You roll a 2 on a number cube and spin a spinner. You have a cube and a spinner. Those are separate events, which means that what happens to the first has nothing to do with the second, so this is an independent event. You choose a king from a deck of cards, and you get a head in a coin toss. So you have cards and a coin. Those are two separate events, so that's going to be an independent event that takes place there. Number 3, you roll a number cube and get a 6, and then you roll again if the first roll is a 6. So I only get to roll again if I get a 6, which means I can't do this unless that happens, so it depends, so we can call that dependent. Dependent. Number 4, probability of A and B happening. Well, the A means I'm going to multiply here, so I have the probability of A is a half, and the probability of B happening is 2/7. So I multiply those together because they're independent events, and I do 2 over 14, which can reduce down to 1/7. For number 5, probability of rolling a 4 and getting tails. Those are two independent events, right? I have a cube and a coin. So the probability of rolling a 4 is 1 out of 6, and then I'm going to do and, there's my multiply there, tails on a coin is 1 out of 2. So I would have a 1 out of 12 chance of getting a 4 and getting tails on a coin if I flip it over, because those are independent events there. For number 6, we have probability of A or B, and they give me some numbers here. When they're mutually exclusive, which is a way of saying they're not connected, they don't depend on each other. So because it has an or, I'm going to add. So I do 32 plus 17 for 49, and I can write that as 49% or 0.49. It's the probability of this or that happening because they're mutually exclusive events. Number 7, high school has 34% take a bus, 56 walk. Probability of randomly selecting a student that takes a bus or walks. A key word there is or, so I have a 34 plus 56. I combine those together to get 90% of the students will walk, or as a decimal, it would be 0.90. Okay? Because we're going to combine those together. Those are, again, mutually exclusive events. It's not the same kids. There's no overlap happening. When we do have overlap happening, as the next problem here, we have to use a little different formula. For overlap, we would do the probability of A plus the probability of B minus the probability of A and B. Okay? So in this case here, A, because it's overlapping, is 1/4 plus B is a half minus the probability of A and B. Well, the and means multiply, so minus 1/4 times 1/2. Alright, so that's how I set that up there. So 1/4 plus a half, I need a common denominator here, is going to be equal to 3/4. And I'm going to subtract from that. 1/4 times 1/2 is 1/8. I need a common denominator here to make that work, so I'll make that an 8. 4 times 2 gives me 8, so 3 times 2 is 6. So this becomes really 6/8 minus 1/8 when I change that to a common denominator. And 6 minus 1 is 5. So I put 5/8 for my solution for number 8. Looking on the back side, the 13 to 16. It says here that I donate 8 baseballs to a local baseball team. My uncle donates 12, so that's a total of 20 baseballs donated out of a total of 50 are donated. What's the probability if the first pitch is one of those balls? Well, it's 20 out of 50, which if you do the math there, it wants to write it as a percent. 20 divided by 50 is 0.40, and as a percent, move it over 2 spaces, and you get 40%. Number 14 through 16, we're looking at a spinner right here. It wants to know the probability of the arrow stopping on a consonant or the first 4 letters of the alphabet. Well, consonants are 1, 2, 3, 4, and A, B, C, D. It means A goes as well, so I have a 1/4, I have a cross it out there. We have 4, 6 plus 1, 6, which equals 5, 6, right? Because we used the word or, I'm going to add that up. Number 15, probability arrow stopping on X. There's one of those out of 6 on the first spin, and so multiply F on the second spin. So 1, 6 times a 1, 6 equals 136. Now the last one here, probability of the arrow stopping on a J or an A on one spin. Okay, so J is 1 out of 6, or means add, and A is 1 out of 6. Just want to add that up. I get 2 out of 6 and reduces down to 1/3. So our keywords here are ands and ors, looking at mutually exclusive events, which means they are independent. And every once in a while they'll throw one in there that is a dependent type of event, like you saw on number 8. So make sure you kind of pay attention to that overlapping one. That's the weird one in the whole thing. All right? Good luck. Hope that helps some.